Okay, this video is about the rusting of iron. So we're looking at what causes rusting, we're looking at how to prevent rusting, and also we're looking at how to speed up rusting. To do this, I've set up a series of experiments to investigate these factors. Now, this is the first experiment. This is called the control, and in the control we've used a nail, and it's got water present and it's got oxygen present. So these are the two things which we think are responsible for rusting. As you can see, there's a fair bit of rust formed within this. The second one here is what we call no water. So I've got the nail, and in the top I've got some anhydrous calcium chloride to absorb any water vapour. As you can see, there is no rusting here. The third one, in this one, there is water but there's no air. So the nail is in water, which I've boiled to remove any oxygen. On top of that then, I've put a layer of oil to stop any oxygen dissolving in the water. So, as you can see, there's no rust here. Number 4 is the salt solution one. Now, as you can see with the salt solution, we've got a lot of rust. There's rust, as you can see, at the top, and also there's a large amount of rust at the bottom. So I'm comparing this to the control, which is on the left. You can see there's much more rust on the salt one. So salt, we can conclude, speeds up rusting. Number 5, this is a galvanized nail. Now, galvanized means it's been coated with a layer of zinc. This layer of zinc is a protective coating on the iron. And as we can see, there's no rust here. So obviously the galvanizing is protecting. Now, next one, this is the same sort of nail, but we've painted it. As you can see, there's very little rust on the nail. So painting seems to be a good way of protecting iron from rusting. Next, again another painted nail, but this time the scratch has been put in it. As you can see, the effect of the scratch is that where the scratch is, the iron will rust. As you can see, there's a fair bit of rust at the bottom, and effectively what will happen in the long term, as it does with most painted iron objects, is that the rust will then lift the paint layer off. So painting is an effective method provided the barrier isn't broken. And finally, I've got here, this is the iron now, but I've attached to that a piece of magnesium, and you can see this time no rust on the iron, and the reason is because the magnesium gives it what we call sacrificial protection. In this, the magnesium, because it's more reactive than iron, this will tend to react with the water in preference to the iron, so this protects the iron from rusting. Now, this is quite common on large engineering projects. For example, piers that go out to the sea, the iron legs are attached to pieces of zinc or large pieces of zinc or aluminium, so they corrode rather than the legs of the pier. You'll find them on ships. They'll put a zinc strip all the way around the hull, so that will corrode rather than the iron. And also in pipelines, they'll be buried at regular intervals. You'll see holes next to the pipeline. Connected to the pipeline will be a piece of wire which will be connected to a bag of magnesium, and the magnesium will corrode first. This is called sacrificial protection. So, just recapping. Normal rusting, we've got iron and oxygen and water both present. If we remove any one of them, so here we remove the water, there's no rust on the iron. Here, if we remove the oxygen, just to remind you, we have no rust there. So you must have both oxygen and water present for rusting to occur. In terms of prevention of rusting, we have which are barrier methods, like the painting. Barrier methods, what they do, they stop oxygen and or water going to the surface of the metal. Or we have sacrificial methods, where we have a more reactive metal and that will react instead of the iron. So I hope that gives you a good understanding of the rusting of iron.